next video, we're going to be talking about the exponential growth and exponential decay functions. So these are equations that we use for word problems. So exponential word problems that are talking about rates. So as you guys can see in this problem, what makes these problems different from problems you may have seen earlier in the year is we now have percentages in these problems. The value of whatever we have isn't growing by a specific number now, it's growing by percentage. So in this one, it's growing by 4%. This one, it's decreasing at a rate of 3%. So that tells us that we're going to be using these exponential growth or exponential decay functions. So as you guys can see from the formula, the reason why we're doing this in the same video is these equations are pretty much identical. The only difference is this sign in the middle. This sign in the middle is the only difference between these two types of problems. Something that's increasing, something that's decreasing. The variables are all the same. They're in the same places. It's just one is plus, one is a minus. This should make sense because if you're thinking about exponential graphs, if we have as our base, in this case it's our base, if our base is a number that is less than 1, so a number between 0 and 1, it means our graph is going to be decreasing over time because as you take an exponent with a base that's a decimal, the higher that exponent is, the graph's going to decrease at a faster rate. Whereas if our base is a number that's greater than 1, that means our graph is going to be growing as time goes on. So this should all make sense. So how do we do these problems? So this first one, it says Drew, me, invest $5,000 into a savings bond whose value increases at a rate of 4% per year. How much will, when I say card, how much will the bond be worth in 6 years? And for all these problems, what I start with is I go through each variable. We have 1, 2, 3, 4. We have 4 variables. I'm just going to write those variables down. So y equals a equals r equals t equals. Those are our 4 variables. So I'm going to write them down, and now I'm going to read this sentence again and try to fill in these 4 spots. So Drew invests $5,000 into a savings bond whose value increases at a rate of 4%. 5,000, 4%. How much will the car be worth in 6 years? So I'm going to try to figure out what each of these numbers mean. If you want to read it one more time, that's fine. So it says he starts off investing $5,000. So does that talk about a final amount, or initial amount, a rate, or a time? That's talking about the initial amount. So in our A spot, we put 5,000. Next, 4%. Anytime you see a percentage, it's a dead giveaway that is our rate. So our rate, our R is going to be 4%. But you guys need to be very careful here in remembering that you represent a rate as a decimal in an equation. So 4% we write as 0.04. And lastly, I'm going to put or. Lastly, how much will it be worth in 6 years? Well, 6 years is obviously asking about time, so we're solving for y. So now we can plug each of these pieces into this equation. So we're still looking for y, so we have y equals, we said A is 5,000 times 1 plus, and we said it's not 4%, it's 0.04 to the power of 6. Now we got to use PEMDAS. So PEMDAS says the first step is parentheses. So if you have something inside the parentheses, you got to simplify that down. Well, we do have something inside the parentheses. We have 1 and 0.04. We've got to combine those, that comes 1.04. Next, PEMDAS tells us you do the exponent. So next we do 1.04 to the power of 6. For that, we're going to need our trusty calculator. I got 1.265. I don't care how you guys round. Or no, this money, so you're going to round it 2 decimal spots. So 1.27. Lastly, we got to multiply 5,000 times 1.27. So I get y equals 6,350. We're very, very close to being done, but we need to read the question again. It says, how much will a bond be worth in 6 years? How much will it be worth? Well, it's not asking what y equals, it's saying how much is the bond going to be worth? So we now need to translate this into context. So this just means $6,350. And that is our final answer. Over here, we're into the same thing. We're just using the minus instead of the plus. So Drew invests $3,000 into a car whose value decreases at a rate of 3% per year. How much will it be worth in 5 years? Again, let's circle all of these, and then I'm going to write down each of the variables. So now I'm going to go number by number, each thing I circled. 3,000, what's that talking about? So it's initial investment, so that's going to be A. 3% is giving us percentage, that's a dead giveaway. It's going to be our rate. And then lastly, how much will it be worth in 5 years? So 5 is our time. Once again, we're just going to plug into the formula. Now for this one, we're going to have a minus symbol. So our first step, once again, we got to simplify the parentheses. As you can see, we have a number that's less than 1. So when we take it to the power of 5, it should be decreasing. So 0.97 to the power of 5. Next step, I got 0.86. So we got y equals 3,000 times 0.86. I'm going to multiply. And I got 2,580. And once again, I need to translate this to making sense in our scenario. This is talking about money, so how much will it be worth? $2,580. And that is it for both these problems. A lot of it just comes down to, do you memorize a formula? Do you understand PEMDAS? Do you understand how to use your calculator correctly? So please just practice, 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 and these problems should not be too bad.